We are talking about the Elixir consensus client today. We are building one of those. And this is our team. This is me. I'm Tomás. And these are the four fellows that are working on this. I'm working also with Martin, with Paul Henry, and with Tomás. The three of us, Tomás, Martina, and the other Tomás, are from Argentina. And we met Paul at the last convention in Paris a couple of months ago. I think it was a couple of months ago. And he joined our team. So we are now the four fellows working on this project. Um, so what are our goals? Why are we doing this? As you can imagine, our biggest priority, which is very similar to why Alessandro is doing his work, which is that we want to achieve better client diversity. Even if consensus diversity is a bit better than the execution diversity, we still think that Ethereum is an ecosystem that thrives on diversity. We think that diversity goes in many ways. One of them is having different clients. One of them is having different languages, both programming languages and human languages, having documentation that can be readable by people, for instance, in Latin America. We also have seen that in Latin America, there are a whole lot of people that are using Ethereum due to, for instance, monetary reasons or just like very into the ecosystem, but there's not so many people in there working in the protocol or working in core features. So we wanted to change that and building a team in South America that was working on the protocol, on a core feature, or in this case, a consensus client was one of our main goals. I'll jump to the third one directly, which is building an open source community. And I think that this is also related to this. Even if Latin America is one of our main goals, we still want to have like a very diverse open source community with developers all over the world since day one. Which is the reason why we are doing open dailies. Like all of our daily meetings are public, and anyone can join the stream and just say hi, ask questions, participate. And even if we didn't yet achieve the first milestone, we already have issues for everybody to be able to collaborate, because we want people to be familiar with the client even like way before this is launched and production ready. And the second goal, I'm saying third, is the working prototype. The idea is that by the end of this fellowship, we have a node that seamlessly syncs with the current beacon state. We want to have something very similar to the other nodes. We won't be supporting validators by the mid-November, because that's probably something that we will not be able to achieve yet. But the idea is that anyone can run a full node using our consensus client by mid-November. And then afterwards, we will continue working on this so that people can be also validators and use this. Next is, okay, why are we working on the consensus layer? Why is the consensus layer important? I think that plenty of people here probably already know plenty of that, so I'll go very quickly. So why a consensus layer? Ethereum, like any decentralized virtual machine or distributed system, needs a way for all of its nodes to be in the same state. It needs a way to know to coordinate what's true and what's not. In Ethereum and in other blockchains, what we have extra is that we have a non-trusted user set and ever expanding. So aside from the regular consensus algorithms like fork choice and the finality gadgets, we also need to have Sybil resistance, which is proof of stake. So basically, we will be needing to implement proof of stake, fork choice, and finality all in our consensus client. Why would we choose Elixir for Ethereum, in this case, for our consensus client? Well, Elixir is a functional programming language, which is very high level. It was originally built for firmware, for backbone router firmware by the company Ericsson some years ago. Sorry, not Elixir. The language I'm talking about is Erlang. Erlang was built by Ericsson. Elixir is then like a more modern version with a more high, no, not more high level. The previous one was pretty high level itself, but Elixir has a friendlier syntax, which is more similar to Ruby. It's built mostly by Jose Valim, who was one of the core developers for Ruby on Rails, so that's why the syntax is pretty similar to Ruby. And it has several characteristics that we love and will be probably very useful for these consensus clients. One of them is that it's very fault tolerant. Elixir is very different from languages like Rust. Rust, for instance, makes a point on making it as safe as possible and making failures extremely rare. Elixir, instead of making sure that nothing ever fails, assumes that stuff will fail once in a while, and just has a very quick and easy way to have supervisors that supervise processes, and when those processes fail, the supervisors just revive them, and you get like a very in the language you have several abstractions for stuff that will revive when something fails. It also offers a lot of availability features. Elixir's preventive scheduler makes failures not condition the state of the system. This means that basically this is very different from languages like JavaScript, where if you have a connection with an infinite loop, that will like highly affect the rest of the system. In Elixir has a scheduler. The Beam, which is the Erlang virtual machine, has a scheduler that interrupts processes that are taking too much time. This basically, like the first and the second point, impact on predictability. This means that latency will not be optimal, but it will be predictable. And this is very important for a consensus client, because this impacts the ability of a consensus client to be able to answer to attestations, to blocks, to any new stimulus from the outside world, and be able to comply to attestation needs and other responsibilities. And it's also a very simple language. It's very easy to learn. Like it's Python level easy. That's the level of easiness we were talking about. So it's very nice to have a language that is so high level, so concurrent oriented, but also that is very easy to learn. So collaborators will be glad to be learning this language, even if it's not one of the most popular ones at this time. So let's jump to the architecture. This is just like a very high level component diagram. We have on the one hand the external parts, but like for instance, what's marked in yellow is basically what we will be building till November, um, which is a consensus node. Outside of it is the validator. The validator is like a separate program in a way. The validator will be using our Bacon API, sorry, not Bacon, our Beacon API to send queries to us, to propose blocks, to get the latest beacon state, to get the current head or the current canonical head according to our node. There's the gossip protocols. The gossip protocol is the way in which the consensus node communicates with other consensus nodes to get attestations, blocks, and also propagate them, and also send our own, when we have validators in, to send our own proposed blocks to the outside world. And then we have the execution client, because like this wouldn't make any sense if we weren't actually communicating with execution, because that's the actual EVM. So basically we have these inputs. We have the validator as input. We have the slot processor, which is just like a clock that once every once every amount of seconds gives a tick, which is what starts a slot processing. And then we have the gossip protocol, which brings us blocks, attestations. This is the most critical part, which is a state transition server. This is, of course, overly simplified. This is actually a very long list of components in itself. But this is the most important part, and it's the one where we will be using most of Elixir's main components, like gen server, supervisors, ETS. The gen servers are like standalone servers that run in Elixir, and the ETS is just a key value store that runs in memory and that allows for concurrent read access, which is something that's very useful for building caches. And then both the Beacon API and the state transition server will communicate with the state cache and the local storage. The local storage is still to be defined. We're evaluating the different key value stores that are used by other consensus clients to see if one of them matches our needs. And then we are already building many of the first steps in these modules as of now. We already have some wrappers around the engine API, and we are already communicating with the execution client. We already have some endpoints on the Beacon API and some endpoints in the gossip protocol. This is just a description of what I was saying right now. And let me go a little bit through the tech stack. These are some of the tools that we will be using when we build this client. One of them is libp2p. There's already a very big and standard library that implements the gossip protocols made in Go. We would love to do this ourselves, but this would be very time consuming and probably would be an EPF project in its own. So what we will do is eventually, when we finish the client, we will probably start building one of these ourselves directly in Elixir. But for now, we are interfacing with Go's existing library. Then we have Broadway. Broadway is basically an auto-scalable consumer for external messages coming from like very different sources. In other projects, we used it for processing Kafka messages or RabbitMQ messages, which are distributed messaging systems. In this project, we are using it to process the Gossip protocol messages. And the idea behind this is that we want to separate parallel tasks, like decompressing the messages and deserializing them with the SSZ. We want to separate that and parallelize it with regards to serial tasks, like beacon straight transitions, which cannot be applied in parallel. Um, Aside from that, we are using the Phoenix framework, which is like it's very similar to Ruby on Rails or Django in Python, but this is the version for Elixir. It's built on top of Erlang's Cowboy server, which is a work of art and a work of engineering, and it's designed for high-load web applications. We used it in other projects that had extremely high loads, so we are expecting to work very well for something like this. We're using Tesla, which is a library for HTTP requests, which we are using for Engine API. And then we have a couple of Elixir standard components, which are the ETS, which I mentioned before. This is the key value store already built in Elixir. We'll probably use this for the block cache. And then we will be using gen servers and supervisors, both for the tick processor, for the, how's it called, for the slot processor, and then the supervisors, which is something that we always use in Elixir to monitor our processes and revive them when something goes wrong. So I will zoom back out. These are our challenges and TBDs, which are the main things that we will encounter in this project. On the one hand, we have plenty of technical challenges, and on the other hand, we will have human challenges. The technical challenges is that as we are tackling this project in Elixir, which is not the most popular language in the Ethereum world, there are some very specific things that will not be available from the get-go to us. That's, for instance, is BLS signing, BLS signature checking, some other cryptographic primitives, libp2p, SSZ. Our strategy for this will be that anything that's very hard to implement and that would take months to implement ourselves, we will just use standard implementations in other languages. And then when we have more time in the future and we all have already coded the core features, we will move to implement them ourselves. As I said, probably will be the first of those because it's not such a big development project. Then the second challenge is load testing limitations. We eventually will want to load test this application because we want to see, hey, if we have like 1,000 messages per second arriving to us, is our implementation full is it proven for high loads? The limitations for that is that having a full node running in your machine is already a challenge. Like you need at least 2 TB of hard drive, and if you also add the networking resources that you need, load testing on top of that is not trivial, and we probably need to find a solution for that. Then optimal storage solutions is the third challenge. The specs are very complete and very interesting, but they don't say anything about storage strategies, which is very understandable. Like there's no reason why Ethereum specs would condition you to choose a particular storage solution, which is great. But at the same time, it also means that you need to do some research on it, which is one of the tasks that we are taking on now. And there's also cross-testing compatibility. Like we need to make sure that our client works with all of the other clients. So at some point, we will need to build a framework for that. Then we have human challenges. One is skill enhancement. We need to make sure that we have a team that is like very well versed on all of the Ethereum specs for consensus, which is like a very steep learning curve. Then we need some distinguishing features. At some point, we will want to gain adoption because if we want diversity to work, we need people to be using our client. And for that, we will need to have features that stand out from the rest of the clients. one of the features that we're thinking about now is observability. I think that having like very visual dashboards to observe the beacon state or forks or amounts of attestations per second, or that could be a distinguishing feature. Some of the other clients already offer some of that. We may make that one of our main things, but we are still evaluating that, and that will be our one of our main challenges. And then fostering a community. We're tackling this from day one, but as I already said, we don't want we don't want this node to just be abandoned once we finish working on it. We want several people outside of our team to be working on this. We want lots of collaborators from all over the world to be using this, and not only to be using this, also to be learning from it. And we want to make the code base as clear as possible so that people learn do how to do consensus clients just by reading ours. So next is our roadmap. We basically did 2-week sprints. The first one is block subscription. We want to have this by mid-September. We are already I think it's the 5th of September, so in a couple of weeks. What we want to have in a couple of weeks is basically a node that you can bring up and is already able to receive and store blocks. And it will have a couple of beacon API endpoints to be so that you can see what's the current, not the current head, because for that you need fork choice, but at least what's the latest block that you received, and you could be able to query blocks using their roots. I think that this is a humble MVP that we can build, and it will already provide everyone with a product, let's say production ready node that they can test and bring up and start building on top of. And our idea is that from our first milestone, we already want something that is in its way production ready and integrating most of our tools so that basically force ourselves to be always working in production. And then I will just give a quick walk through the other ones. The second one is checkpoint sync. We want to from the first milestone, we will be able to sync from a current standpoint and to the future blocks. The idea from checkpoint sync is that you can you can perform checkpoint sync and get all of the previous beacon states. So actually you get prepared for the third milestone, which is attestation processing. At this stage, we will have beacon state representation and we'll be processing attestations. Afterwards, we will be processing deposits, BLS signatures. And then the fifth and sixth milestones, we put mid-November in both of them, because at this point we will probably have more people collaborating with us, and we ourselves will be way more familiar with the consensus specs. We are actually way more familiar today than a month ago, so we expect to be like very well read on that. And we will have, but the idea is to have for mid-November both fork choice, which is Ghost LMD, and slot processing, and on the other hand, finality, which is Casper friendly finality gadget, and slashing. So basically, mid-November is where the EPF ends and where Dev Connect happens. So we want to have this for the Dev Connect and the end of the APF, and then afterwards we still design the next the following two sprints, which are rewards, shuffling, and the validator features. But the idea is to have for the 6th week an already working node that anyone can use to bring up a full node and do basic interaction with it. Like if they, instead of using Infura or MetaMask or Alchemy or whatever solution that's fully made for you, if they want to send their transactions using their own client, they should be able to do that by the end of the APF. That's our main goal. And I think that's it. We have we could be talking about this for hours, but I wanted to make this as quick as possible so I could leave some room for questions. And I think that's it for now. Are there any questions here?
Awesome. Thank you, Tomas. Marcos does have a question there in the chat. Marcos, if you want to voice that over audio, that would be great.
I can read it as well. It says, if you interface cryptographic primitives from Elixir, would that create potential security leaks? How could you deal with that? I'm not sure what the source of the security leaks would be, if you care to elaborate on that. If the library is as is well proven, then the connection in itself, interfacing with a different language, wouldn't cause the security leak itself. I think the challenge for us there is that if we are not building the library ourselves, we should have a very careful audit process to make sure that the libraries are good, like cryptography primitive cryptography libraries. This is a bit outside of the scope of the presentation, but in terms of BLS, for instance, which is one of the biggest cryptographic primitives here, we are planning to integrate with LambdaWorks. LambdaWorks is a cryptographic library built by other people in the company I work for. And they already have like plenty of Stark and Snark and ZK primitives built, and like finite fields and that kind of stuff. And we're working alongside with them so that they can build BLS, and eventually we will be integrating with them. So we don't have, we won't need to be as careful with an external audit with another team. Like if we were incorporating an audit from a project we don't know about. I don't know if that answers the question. Like, please elaborate if it didn't. And
All
also, I
right.
think, yeah, sorry, go ahead,
Yeah, go
Josh.
ahead. Yep.
Yeah, I think that there was one more question, which is, it said, can you elaborate more on fork choice and how you will implement it? I think that this is very long to talk about in this meeting. Um, we can continue that discussion in Discord or in Telegram. Fork choice is like, there's very concrete specs on how to implement fork choice. Um, but I think that on the one hand, there's like the only unknown for now is how we will implement storage and how we will implement cache, because the specs are like very clear on the pure and functional part, but they are not very clear on how you need to implement storage, cache, and that kind of stuff. So that's probably the optimization parts that will be the hardest for us to plan for.
I am curious, is it just the four of you in from EPF working on Elixir right now, or are there other people from Lambda or other solo contributors also working on the project?
Yeah, from Lambda, it's just the fellows. It's just the team that I mentioned a couple of minutes ago. But we are already getting some collaborations from the outside world, especially with regards to SSZ and some regarding to interfacing with libp2p. So yeah, we are already getting some comments, some PRs. We hope that this will be greater as the project continues. But yeah.
Great. And then I'm also curious, like how confident you are in your timeline here.
That's a tricky question, but I think that's the idea. I'm like, I don't know, 60% confident. Like, I'm expecting to have a very useful thing for the end of the APF. I also know that it's extremely challenging to have all of this coded by November. We're not that far from November. I think that my confidence will either improve or be reduced in the following month when we know a little bit more about the development process, about like, hey, how hard was it actually to implement fork choice? Like we already have a good idea, but we still don't know the details until we start implementing it. So yeah, maybe 60%, and maybe we can ask the same question in a month, and we'll have like either better or worse confidence.
Yeah, great. Thank you. Great presentation. And yeah, looking forward to reading all of you guys' development updates as you progress through this.